Okay, picking up right where we left off, we have more with function notation and evaluating functions using operations. I don't know why that blue box is there. Oh, there we go. All right. Given the graph to the right, find g of f of 4. So we're going to take 4 and sub it into function f, which means I go to 4 and I read on function f, which is the filled in black line, and I get 2. So this whole thing is now just a giant 2. Which means what I really want is g of 2. So I'm going to go to 2 and look for the output at g. So 2, g is the dashed line. The output is, oh, look at that, also 2. All right, this one, g divided by f of 1 is the same thing as taking g of 1 divided by f of 1. So g of 1 means go to 1. And read the output at g, which happens to be 1. Then go to 1, read the output on f, which is 3. So final answer, 1/3. Okay, so inputs and outputs. Your function notation was from early in Unit 2. More specifically, operations on functions would have been video like 2.7. So you might want to go back and look at those if you're struggling with number 6 or number 7 from this review. All right, find the inverses. Oh boy, inverses. General rule, you're switching your domains and your ranges. You are reflecting over the line y equals x. The point xy becomes the point yx, right? We have these 4 steps for how to do this. Most of you understood the 4 steps on your most recent test. The problem was remembering about restricting the domain, if necessary, okay? And then making sure that you solve for your y variable correctly. So let's think first about x minus 5 to the 3rd plus 2. So that's going to be a disco man graph, x to the 3rd, which looks like this. That's been moved to the right 5 and up 2. So maybe somewhere like this. When we think about this, does this graph pass the horizontal line test? Yes, it does. So will this function have an inverse that is a function? Yes, it will. So step 1, switch f of x for y, just for notation's sake. Step 2, this is where the magic happens. Switch all x's with y's and y's with x's. So you are physically making that reflection. You are changing out your domains and your ranges. The next thing then is to isolate y. So to do that, I'm going to start by subtracting 2. Next thing I need to get rid of is this cube. So I'm going to take a cubed root. So I get the cubed root of x minus 2. When we take a cubed root, you don't have plus or minus because it's an odd power. This will be equal to y minus 5. So the last step then would be adding the 5 to the other side, which you can do in front. Or you also could have cubed root of x minus 2 plus 5 written like that. Either one, okay? And because your function started 1 to 1, you did not have to restrict the domain. Well, let's look then at b. b is a squaring function. Okay, so it's a parent parabola, not a disco man. That parabola will have been shifted. There's our original parabola. Shifted to the left 1 and down 4. Well, this right now does not pass a horizontal line test. So you need to pick 1/2 of your parabola. If I pick this side, it's going to be that x is greater than or equal to -1. If I would have picked this side, it would have been x is less than or equal to -1. You need to pick either one. I'm going to go with the blue one first. Okay, I'm going to show you both. I'll do the blue one over here. So y equals x plus 1 squared minus 4 with x greater than or equal to -1. So when I switch out my x's and y's, I have to switch out my y, right? X becomes y even in the domain, right, which is now a range restriction. From here then I'm going to add 4 to both sides. I'm going to take a square root, which gets me a plus or a minus. And then I'm going to subtract 1 to the other side. Okay, well this is where you can then see you were supposed to carry through that y was greater than or equal to -1. So here's -1. Am I going to want to add stuff to that, or am I going to want to subtract stuff to that? Well, if I'm supposed to be greater than or equal to -1, I'm going to need to add the square root of x plus 4. So now let's think about what would happen if I had started with, instead of x is greater than or equal to -1, if I had started with x is less than or equal to -1, this line here would have been y is less than or equal to -1, which means when I get down to my final answer, I would have wanted to take -1 minus the square root of x plus 4. So it doesn't matter if you restrict and do the blue or the green, but you need to pick one or the other. So your final answer here is -1 plus the square root of x plus 4, because y is greater than or equal to -1, or in this situation, because y is less than or equal to -1. These square roots have a domain that's based on this plus 4, but it's not asking you to restrict the domain of the square root. We had to restrict the domain of the parabola, because that's the thing that didn't pass the horizontal line test. This is all in video 2.8. If you need a refresher about how to deal with inverses, 2.8 is going to be where you go. All right, now we're moving into trig, starting with unit 3. So solve the right triangles below. That is, find all missing angles and sides. Well, I need angle B, I need side B, and I need side A. Angle B is going to be pretty straightforward to find because you can just subtract from 180. So 180 minus the 90 in the right angle minus the 36 will be equal to angle B. So angle B ends up being 54 degrees. To find side B, here's side B, which in relation to 36 is the adjacent side. And here's 10, the number I know, which is the hypotenuse. The reason I'm going to use 36 is because that's what's given to me. So I want to rely on the information provided. Well, what relates the adjacent and the hypotenuse? That's going to be the cosine function. So the cosine of 36 degrees will equal B over 10, which means that B equals 10 cosine of 36. Make sure you're in degree mode in your calculator. You should end up with 8.090. Next then, if I want to find side A in relation to my 36 is opposite, and 10 is still my hypotenuse. So this time, what relates the opposite and the hypotenuse? That's going to be the sine. So the sine of 36 is going to equal A over 10. Multiply both sides by 10. A will be equal to 10 sine of 36, which comes out as 5.878. Okay, next triangle. Next triangle. I'm going to erase this work here. Great. Already solved that one. Don't need it anymore. All right, cool. This next one, I need to work to find side C, my last remaining side. I need angle A, and I need angle B. Well, just like the last one where I used properties of triangles to find my 54 degrees, here to find C, I can rely on the Pythagorean theorem. Remember, the Pythagorean theorem says a leg squared plus a leg squared will equal the hypotenuse squared. Okay, or A squared plus B squared will equal C squared, which is conveniently labeled C for us. This ends up being 4 plus 9, which is 13, equals C squared. So C equals the square root of 13. Reminder, technically speaking, C equals plus or minus the square root of 13. We don't want to forget our algebra skills. But because we're talking about the distance, right? The distance we're going to keep as our positive square root of 13. All right, well now I've got the square root of 13. Great. Next thing that I'm going to do is I'm going to work to find angle A. So angle A is right here. I want to use the information given to me. So 3 is going to be the opposite from A, and 2 is going to be the adjacent to A. and it is going to be tangent that relates an angle, A in this case, with its opposite and adjacent sides. So to get A by itself, I need to get rid of or undo tangent. So I'm going to take the tangent inverse of both sides. If I do that on the left, got to do that on the right. So on this side, I get A, and on this side, I get tangent inverse of 3/2, which I will type in my calculator, and I end up with 56.310 for rounding purposes, and that's an angle, so that's going to have degrees. Okay, then let's talk about finding angle B. Here's angle B. 2 in relation to angle B is now the opposite side, and 3 is the adjacent side. So to find angle B, I'm going to do a similar process relating opposite and adjacent, except this time instead of A, I've got B. So tangent of angle B is going to be equal to the opposite over the adjacent. I'm going to take that tangent inverse of both sides, type that into my calculator, and I end up with 33.690. Now, some of you are like, Ms. Schwartz, why did you just do all of that work? Couldn't you just have done 180 minus 56 minus 90 and gotten the 33? Sure, absolutely, 100% can do. To be honest, I kind of forgot that I could do that real quick. But also, I think it's important that you see the tangent inverse again happening. One last thing to think about, you should always consider the relative size of your triangle. And what I mean by that is that there's a rule in geometry that says the bigger the angle, the bigger the side. So side C is across from 90. This should be the biggest angle, okay? Then 3 is the next biggest side. So A should be the next biggest angle, 90 down to 56. Okay, great. Then this is the last, or the smallest side rather. So B should be the smallest angle, and that checks out in how I've done all of my calculations. Okay, give it in degrees, write the answer in degrees. If in radians, write the answer in radians. Please keep all answers exact. I'm going to say when possible, okay? When we get to these ones that are radians without the pi's, you can round to decimals a little bit. So convert 125 degrees into radians. I multiply by pi over 180 because there's 180 degrees in every pi radians. Using math fraction in my calculator, I just do 125 divided by 180. That gets me a fraction of 25/36 of pi. Okay, so I've gone 25 out of 36 wedges around the top of the coordinate plane. For B, converting this one will be from radians to degrees, so I'm going to flip my fraction, my conversion factor, 180 degrees over pi radians. My pi's are going to cancel out. I'm going to end up with negative 7 times 180 over 5, which is negative 1260 over 5, which is really negative 252 degrees. Okay? Last one, I know I'm starting in radians because there is no degree bubble, which means that to convert to degrees, I want to multiply by 180 over pi. So I'm going to multiply straight across, and I end up with 810 over pi. And this is weird because this actually is a degree measure. Okay, I went from radians to degrees. So don't just assume that because there's a pi in your answer, you were in radians, or because there's not a pi in your answer that you were in degrees. The indicator for degrees is literally the degree bubble. Okay, so this one had a degree bubble. That's how I knew I was starting in degrees. These ones didn't have degree bubbles. That's how I knew I was starting in radians.